about the tire turning thing you were talking about? You think that affects it?
Well, I'm just guesstimating probably about, it turns about 400 times in a mile.
That's just guessing calculations?
Yeah, I don't know how you work that out.
It'll be tough.
Yeah, so, I don't know, because if I run a mile in like 9 minutes, then, I mean, but that's when I'm out of shape. When I'm really in shape at like 7 minutes.
She's not narcissistic, okay? It's not about her, okay? Just wanting you to know that.
I'm running at about probably 10 miles per hour.
God, I feel sorry for that guy.
Yeah.
And that's
Married.
faster human being. But, I mean, it's going to take at least like 58 minutes or something.
58 minutes? It's pretty close.
That's pretty close, honestly. Pretty darn close.
Think about 80 miles per hour. So how long does it take me to go 80 miles? I'm traveling 80 miles per hour.
You are driving faster than a minute a mile.
Yeah, totally.
So I would half, and that's 40. I mean, you're probably going 2 minutes a mile.
Whack it in half.
Well, depends on. I mean, sometimes tires turn faster than others.
Yeah, definitely fix it.
I mean, I think a truck probably is slower because it weighs more.
Mm-hmm.
But I think it also matters if your car's a stick or automatic.
Okay, Sean.
What?
Think about the term miles per hour.
MPH.
MPH. So if I say I'm driving 80 miles per hour, that means I'm going to go 80 miles in an hour.
No, you are not, because you are driving faster than a mile a minute. You run 1 mile in 7 minutes, and that's a 10. Okay? So I mean, that's booking it too.
Okay, so if I'm going 60 miles per hour,
We should go 1 mile
It
every
would take
minute.
about 30 minutes.
Yeah.
I would just cut it right in half.
Wouldn't laugh. You married this person.
Well, you don't
I guarantee they're divorced. How much
I
more
make sense. You do not make sense.
They're just gonna have stupid kids.
Huh?
Just gonna have stupid kids, but they'll probably stay good.
Police officers' tires that are full, but
The tires are pretty full, they'll go slower.
okay, tell the
my
answer.
tires are pretty, maybe, I'd say about 400 times per mile.
Okay, I'm going to tell you the answer. You ready for the
No, they gotta
answer?
be like 1,000.
You ready for the answer? The answer
You
to...
don't know the answer.
I do know the
You
answer.
can guesstimate just like I guesstimate.
I'm not guesstimating. I'm using math, science. I'm using my own term. Okay, Chell. The answer to the question, how long does it take me to travel 80 miles if I'm driving 80 miles per hour? The answer is 1 hour. Your guess was
So
close.
say you drive 60 miles per hour at 60 miles.
For
You want to
60.
go 60 miles at 60 miles per hour. Is that an hour?
Yep.
What about 40 miles at 40 miles per hour?
Then you'll go 40 miles, 1
Oh,
hour.
you cut that in half. You're going more than a mile a minute.
Had a kid together.
See, let's time.
You're kidding.
Right now. Let's time and see. He's not floating.
God, I can't believe they're still married. Anyway, guys, run. That's the question you need to ask.
Great world geography question.
Shut up. Okay, that's what you got to do. If you go on out a date, ask that question, and if they give you an answer like that, just go ahead and open the door and kick them out. Okay? Girls, same thing. If they can't answer a question like that, kick them out. Now, why did I show you that question? Well, my ebook's not working. So I got here at 9 o'clock to go over the ebook to pick out problems, and the ebook wasn't working. So I had to go through, and in my 45 minutes after the IT person couldn't fix it, I had to go through and fix some things. So I had to rework class today in about 45 minutes. So what I want to show you is, if I asked you this question, if you travel 50 miles per hour, and that's 50 miles per 1 hour, and I also told you that you traveled for 3 hours. Now, everybody in the class, hopefully, would say, okay, 3, that'd be 3 hours up here over 1, and hours would what? Cancel, and you're left with 50 times 3, which is what? 150. 150 miles. Now that's mathematics behind how you got 150. Now some of y'all say, just multiply 50 times 3. Yeah, that's true. This is the mathematical definition. You could also say, well, I'm going a constant rate of 50 miles per hour. So y is equal to 50. And here is 1 hour. Here is 2 hours. And here is 3 hours. Now we all know that the area of a rectangle is equal to length times what? Length times width, or base times height, or length times height, or base times width, whatever you want to call it. So we know that the height of this curve is 50. And we know that the length is 3. So 3 times 50 is what? 150. And that is the area under the curve. Which we know the area under a curve, this is not a curve, this is a straight line. But you could easily change this to a curve, and we would be finding the area under the curve. All right? Now, I'll be honest with you. I looked over the book last night, and it's like I was telling y'all the other day. The only new material is in 5.7 and 5.8. Maybe a little bit of 5.6. Okay? So all of the chapter 4 and chapter 5, all of that material is review. And 5.6, 5.7, and 5.8 goes into the area under the curve. Now, what we're going to do today is we're going to find the area between two curves, and we're going to find the average. Okay, but we got to do a little bit of, what was that? We got to do a little bit of going over a couple of things before we do that. But anyway, I kind of gave y'all this same thing with the area under for the garden, for the length of the yard or whatever. In Foxtrot, I gave you that, but this is just a little bit of what they're going over in 5.6 and 5.7. They wasted a whole lot of paper in this book. Let me tell you, I'm glad it's online, because that's a lot of wasted paper in chapter 4 and chapter 5. Now, let's say I give you a antiderivative, or I give you a function, and I bound that function by parameters. Let's say I go, the f of x is equal to x squared plus 2. And I tell you that a is equal to 0, b is equal to 9, and x is equal to 0, and y is equal to 0. Okay? So go ahead and look at, I want you to graph this function. Go ahead and graph it. I want you to graph it by hand, because it's not going to help you to graph it on a calculator, because you're not going to see everything. So if you got a piece of graph paper, that would be great. If not, take a straight edge and draw a first quadrant and draw this function. And basically, we're going to take the antiderivative And we've already covered this, but I'm using x squared plus 2. I'm going to show you what happens when this right here changes to another function. Like that. Okay, so I'm trying to merge you from going from the antiderivative, finding the area under curve, to finding the area between two curves. Okay, so just bear with me. I know what I'm doing, believe it or not, no matter what you hear. So x squared plus 2, that means a vertical shift of 2. So that means 1, 2. And we've basically got a parabola that looks like that right there. Okay? And going from 0 to 9, 3 squared, 9 squared is going to be something huge up here. Let's change that to 2 squared is 4 plus 2 is 7. Let's change that to 2. Okay. Okay, so now y is equal to 0 is the x-axis. So that takes care of anything below the x-axis. That takes care of the negatives. Then y is equal to 0. X is equal to 0 is the y-axis. That's going to be bounded by that right there. Okay? And then from 0 to what? 2, and I'll do that in red. 1, 2, and 2 is going to give us what? 7. So 1, 2, 3, 4, 5, 7. So there is our area that we're wanting under the curve.
Where did you get 7 from?
X is equal to what? B is equal to what? 2. So 2 is the furthest we can go. So what do I do with 2? Plug it in, you get 2 squared is 4, that's 6. I'm sorry. Oh, I can't. 2, 3, 4, 5, 6. Sorry about that. No, you're just trying to make me look bad. I know exactly what you're doing this to do. Trying to make me look bad. Russian. That's what it is. You want to call discourse. So if you want to take your handy dandy eraser, erase that, erase that, erase that, and pretty much I'm not going to erase that y-axis because that kind of gives you an orientation. So, but the area is between the green, the yellow, the red, and the black. Now, in the book, when they're in 5.6, they tell you to take a green marker, and they tell you you can put a rectangle there and a rectangle there, and use Riemann's sum, which means take your length times your width. What's the length? What's your width right here? 1. And what's the height here? Let's see, 1, 2, 3. And then what's the length here? 1. And what is this? 3, 4, 5, 6. And what's 3 times 1?
3.
And what's 1 times 6?
6.
So the area under this curve is around 9 square units. All right, now write that down because I just showed you Riemann's sum, or Riemann's sum, whichever, hold your pinky up. I just showed you Riemann's sum in this little bit of area, which takes the book 4 or 5 pages. Okay? You take the length times the width and the length times the width, and you add them. Yes, ma'am. So if you find another mistake, just
No,
leave.
it's not. How can you take the area like that because it's still taking the area of that whole box? Because isn't that including that?
Exactly, it's an estimate. That's why I put the little squiggly line right here.
Okay, so it's not the exact.
No, it's not exact. Now you could go the opposite way And you could do this. I'm going to take the blue marker, and you could go the opposite way and say, well, I don't want too much. Well, go the other way and do this. Okay, there's my blue right there, and right here you would have this one like this, and that's about all you could do. And then you would do 1 times 1, 2, that's 2, and then 1 times what? 1, 2, 3, right? 3 times 1 is 3, and that's equal to what? 5. So you know your area is between 5 and what? 9. I would say probably 7. All right? So you would take this estimate of Riemann or Riemann, whatever, and you would say that I think the area is around 7. Okay, so I just showed you Riemann's sum. Now, the smaller you make the rectangles, the what? The better, the more accurate. Therefore, you throw in the limit in there. See, we're not dealing with the limit right now. You throw the limit in there, and you make the rectangles the width of a hair, then you're talking about this area right here being that area right there being very small, and this area being very small no matter which way you're going. So you throw the limit theory in there, you're going to get the closest answer. So let's go ahead and do that. Let's do our antiderivative. And let's say the antiderivative of x squared plus 2 dx at 0 to what? 2. All right, so that's going to give us x to the third over 3 plus 2x evaluated at 0 and 2. I'll do 0 for you. I'll calculate that in my head. Now you do 2. So 2 to the third is what? 8, Hubert. Good, class. 8 over 3 plus 4 over 1. 8 over 3 plus 12 over what? 3. What's 12 plus 8? 20 over 3, and 3 will go into 21 7 times, so I'm going to say that this is around 6.9. So somebody take your handy-dandy calculator and tell me what the area under that black curve is. Come on, calculator drill team. You know, the ones that can twirl it on their finger like a basketball.
Do you want 20 divided by 3?
20 divided by 3.
It's 6.6.
6.67, 6.7. Okay, 6.7. Sue me, I was off. 6.7. So even with no clue on how to do calculus, I came up with 7. This right here is nothing but 100% what? Say again? Algebra / geometry. Okay? You throw Riemann's in there and you throw the limit theory in there, which takes those rectangles down to a hair, and then you have 6.7. Now, let's take this same picture. Let's take x squared plus 2, and let's find the area between another curve. All right? Does everybody understand this? Does anybody have a problem with it? Okay? This is your boundaries. This is your question. This is your boundaries. Let's mark that out. Okay? This is your boundaries. This is Riemann's, graphing it and applying Riemann's theorem, which is 100% algebra. And this is the calculus. The only calculus is right here. From here to here is calculus. The rest is algebra and math. All right, so let's take x squared plus 2. And I want you to graph it. F of x is equal to x squared plus 2. and g of x is equal to x. So graph that. And I want you to use a straight edge. You got a dang old ID, dang old credit card. Graph it. Try to be accurate. We still got everybody. I see Pendleton. Okay, I see Easley. Mr. Miller's in the middle of the little speck in the middle of the screen.
Yeah, I'm here.
Yep. Dang old folks, camera don't work. Dang old laptop, cheap. Gotta quit getting drunk and falling on your laptop, Mr. Miller.
I don't do such things.
Don't you live in Richland County? You ride around with your speakers wide open selling drugs, don't you?
He lives in the mean streets of TK.
Say again?
It's the mean streets of TK.
Exactly, man. Oh, you're in Tigga Is that where you are?
Yeah.
My uncle lived in Tigga He lived right beside Jim Baker. Well, Jim Baker got kicked out of his house. But
Jim Baker.
yeah, Jim Baker, the preacher.
I don't know who's Jim Baker.
My uncle lived in Tigga
I know Jim Baker. Oh, Jimmy?
Yep.
my uncle lived right
Dang old snorted cocaine with that woman. What's her name? Got her in trouble. Dang old witch
Jim
jail.
Baker sold cocaine.
Why you think that's what people in Tigga do, man? They sell cocaine. That's what Mr. Miller does.
The entire economy.
I wish I knew my uncle's address. I'd see how close you are to him, but that's a pretty big subdivision. But he was a McClure though. But he was.
Where's it at?
Rock? Is it right near Carowinds? Right? Rock Hill, whatever. What's it called?
Yeah.
Where's Tigga It's right on the state line.
Yeah.
Whereabouts is it? What county is it in?
York.
York. Yeah, that's it.
York County.
Dang old right below dang old Charlotte, dang old South Carolina. Dang old Carowinds. All right, so here we go. We got that 2, 1, 2. We know that the parabola is going like that. Everybody with me? And then we got x, which is a 45-degree angle, 1 to 1. 1 to 1 is right there, so we're talking about, okay? Now, I don't know if it crosses or not. In fact, let's change it because I want to get it to cross it. So what I'm going to do is just take off. I'll make it easier for you. Let's do this. Okay? So that will bring this parabola which way? Down.
Down.
But you're supposed to know that. So I'm just going to change it and bring that parabola down to here. How's that? Now I exaggerated it a little bit because now we have the area between what? 2 curves. Well, we should go ahead and quit because this is too what? Too complicated. So when the tough gets going, what do you do?
Quit.
Throw your pencil down. Yep.
If I've learned one thing from your class, Hubert, that's it.
Good. I'm glad you finally, participating in class. Did you go to Waffle House 2 this morning, or just
Something like that.
or did you just try to sneak in? What is it?
I didn't try to sneak in. I never tried to sneak in.
Oh, I know. You're a good student. You're very studious. All right. So, what do you do
Good.
besides quit? Well, Hubert, you didn't give us A and B. No, I didn't, because you got to calculate it. How do you calculate the intersection points between 2 curves?
Calculator.
Use the calculator. No. You set them what? Nope, that gives you the x-intercepts. You set them equal to each other. So set them equal to each other. and then you'll end up setting them equal to 0, but you got to set them equal to each other first. So we're going to have x squared is equal to x. So over here, now this is what you need to do. Step 1, you need to graph. So we're going to put step 1 right here. Step 2, find intersection points. So x squared is equal to x. X squared minus x is equal to 0. Oh gosh, we got to depend on that algebra again. Y'all notice we haven't even done any calculus yet. X times x minus 1 is equal to 0. X is equal to 0, and x is equal to what? 1. So x is equal to 0. That's an intersection point. And x is equal to, I'm going to change this scale right here because it's not right. X is equal to 1. Now you've got your A and B. A is equal to 0 and B is equal to 1. So you need to write that down. A is equal to 0, B is equal to 1. Okay, now we got to throw in the calculus. Are you ready? To find the area between two curves, you subtract them. A to B of f of x minus g of x dx. And then take the antiderivative of that function. All right, so I want you to fill out the antiderivative now. How do you know which one's f of x? Well, plug in 0.5. Somebody plug in 0.5 right here. I'm going to take a blue marker and I'm going to plug in 1/2. Okay, because 1/2 is going to give me two y values, right? Yes or no?
Yeah.
Yes. The higher value is going to be your f of x. So, 1/2 gives us 1/2 with x. What does 1/2 give us with 1/2 squared? I'm sorry, what? 1/4. So, which one's the bigger value? X. So, this is going to be f of x. And this one is going to be g of x. All right, plug it in. After you plug it in, the only thing you can do is break it up and take the integral of both terms and plug and chug the math in. Antiderivative from 0 to 1 of x minus x squared dx. Now luckily there's nothing you can do except break it into two antiderivatives, or just take the antiderivative of the whole thing and plug and chug in 0 and 1. I'm going to give y'all a second to do that.
Did you write that backwards?
No. F of x is a straight line. Oh, I'm sorry. Yeah. G of x, it's going to be g of x minus f of x in this case because f, that's supposed to be g of x. I'm sorry. My bad. Okay. G of x, and I need to change it right here. You take the upper value and you subtract the lower value. In this case, it's going to be g of x minus f of x. Doesn't really matter what insignia you use, just so long as you do the upper value minus the, and this is the upper value, which is g of x. Thank you. And this is f of x. And that's why it's always good to plug in a point, and that's why I plugged in 1/2. Why didn't I plug in 0.5? Because not many people know what 0.5 to the second power is. But you know what 1/2 to the second power is. That's 1/4. So that's why I did that. Here, what is the antiderivative of x? X squared over 2, Hubert. And what is the antiderivative of x cubed? I mean x squared over 3. And that's going to be evaluated.
Have the arrow thing and drag it.
I'm sorry, what?
We were just trying to fix your thing on our screen.
Oh, okay. Evaluated at 0 and 1. I'll plug in 0 for you and calculate it. 0. Now you do 1. Let's see, what's 1 squared? Don't be like my neighbor. Come down here and figure out how to use this blame calculator. Yes, ma'am. Go down there, and she bought a calculator for her daughter. And she said, we're doing this problem, and it says 1 to the 29th power. And I put it in this calculator 5 times, and it keeps giving me 1. How do you tell your neighbor that, let's see, how do I put this, that they're challenged? She didn't know that 1 to the 29th power was 1. I tried to be gentle. I tried to tell her that, you know, a lot of people get confused with that. All right, so 1 to the second power is 1/2. I mean 1, and then 1 over 2 is 1/2. Minus 1/3. Got to have a what? Common what?
Denominator.
So that's 3 over 6 minus what?
2 over 6.
Which is 1 over 6. So your area right here is 1/6 or 0.67 or 0.16. Is it 0.17? Sorry. 0.17 square units. Square units. How many of you seen Beautiful Mind?
I have.
Okay, it's a good movie. One person. Okay, good. That goes to show you. There's always cream of the crop somewhere, whoever said that. All right. Beautiful Mind. And when the bar scene, after he figures out about the blonde and his friends and all that, and he finds out this equilibrium, he goes back to his dorm room, and you see him drawing these vector fields, and he has this, and he has this, and then he has this right here. Remember that scene where he's doing that? He's finding the area between two curves. He's using calculus, and he's using economics, which some of y'all are going to be heading toward when you're doing marketing and doing business. You're finding the area between two curves. Okay? So that's what you're doing. And you feel good about yourself, correct? Yes, no, maybe?
Sure. Yeah.
Or do you have smokestacks on your 85 Honda? All right, so let's do another one. So, third, another thing you need to remember, either the intersection points can be calculated because they intersect. That's why it's important for you to graph it, either on a graphing calculator or by hand. If the two functions intersect, then you have to calculate. But what if they don't? You quit and go to the next problem, right? Cannot be done. That's what you say. Not enough information, right? Intersection points given when the two graphs do not what? Do not intersect, or they do not intersect in the values given. Okay? In other words, the first quadrant, they may intersect in the third quadrant, or the, way beyond the first quadrant out of the parameters that have been set. So, there's two types of problems. There is one where they actually intersect, and then there is when they do not intersect. So you have to be sure you read the what? The question. All right? Then the first thing you do is you graph it. So, this question says y is equal to x squared plus 1 and y is equal to x cubed. Now this is the question I got from one of the books online, and of course some math teachers would have a conniption. Why? Because both of them are written to y. Okay? Some people have a conniption over that, but it's not a big deal. Alright? They say from negative 1 to 1. Now, I don't know if they calculated it, but the question, they give you the points. Alright? So, if you set x squared plus 1 be x cubed, be x cubed, yeah. You don't want to try to calculate because you're going to have to use long division, 2 or 3 steps. So that's why they gave you the points. Now, first of all, go ahead and graph it. While you're graphing, I'm going to pull up the handy-dandy calculator. So just bear with me a moment. I don't need anyone telling me, I can't see. Hold on a minute. Darn, I didn't know that one was on there. That's a sophisticated one. I don't know if I'll know how to use it or not. Let's see, get rid of this. And get the calculator again. I'm going to have to move this over. Y'all bear with me a minute. Hold on. Move this over. Things I do for y'all. There you go. Dang old turned on the fire stick last night. Dang old Deadpool was on there, but I couldn't get it to come up, so I'll have to keep trying. I thought of you. I thought of you. What?
Hey, let me know what you think of it when you get to see it.
Not too much of the first one, but that was just me. But I understand different strokes for different folks. He's a little bit on the vulgar side. He's a little bit on the adult side of the Marvel comics, isn't he?
To say the least.
Well,
Yeah.
Isn't this like the only R-rated Marvel movie?
Yeah. Got to get that in there somewhere, don't they?
The best
All
thing is when parents still brought their little kids to the movie.
Yep, exactly.
Hey, that one gets bad.
Yeah, they just
Dang
leave in the
old
first
Marvel
3
porn.
minutes.
All right. Y is equal to x squared plus 1. So x squared plus 1. And dang old, I'll go over here and I'll put make that dark and put x cubed. So x cubed. Dang old graph.
You gotta change that.
Guess your Y1.
Okay, hold on. Let me. What?
The plus 1.
Y1, you gotta press over.
Whatever.
Squared.
Oh. Dang Russians. How did I get plus 1 there? Oh, I know how. Okay, delete. I didn't move over. I suck. Plus 1. There we go. Okay, there's that. And then there's that. So we're finding this little area right in here, it looks like. -1 to 1, right in here. But you see why they gave you the points, because they only intersect at one point right here. So they had to give you something. And plus, it's a pain to set those equal to each other and then factor out the x. You can't factor out an x. You have to use long division and see if x is factorable into it. So it's just a pain. So that's why they give it. So the whole point is, dang old, this is a problem where they actually give you the points. So you do not have to set them equal to each other. You just have to find out which point is more of a value. So plug in 0. 0 gives you a 1, or 0 gives you a 0. So it looks like this function is the superior function. So I'm going to antiderivative from -1 to 1. And that's going to be x squared plus 1 minus x cubed dx. Now I kind of put it in parentheses so you will know to go ahead and break it up. Okay? Miss Kubu, that looks so nice. You coloring that in right there. The rest of y'all, yours looks like crap. I know. Yours does too. Miss Kubu, you did good.
Thank you.
She took a little red pen and she colored in the area. Did you do that, Mr. Crawford?
Yeah.
No, you didn't. You playing on the computer. You watching porn on the computer, probably. dang old Deadpool porn or something.
What the hell is wrong with you? What the hell is wrong?
You can take it. You're tough. All right. So we got the antiderivative. So let's go ahead. What's the antiderivative of x squared plus 1? X cubed over 3. And you can go ahead and evaluate that at -1 and 1 minus x to the 4th over 4, evaluated at -1 and 1. Or you can just leave the evaluation at the very end. No. And you can just say evaluated at -1 and 1.
Would you not have to add another x for that 1 if you're doing the antiderivative?
Yes, you're right. Thank you. I was thinking of derivatives. There we go. Thank you. I was doing the derivative as 0. That happens, okay? Sometimes when you're doing the antiderivative, you think of the derivative. So don't do that. I just did it because I took the derivative of 1 and dropped it off. So thank you. All right? What else? I think that's it. So let's go ahead and I'm going to rewrite everything over here. And I'm going to say parentheses cubed over 3 plus parentheses minus parentheses to the 4th over 4 minus bracket parentheses cubed over 3 plus parentheses minus parentheses to the 4th over 4 close bracket. And now I'm going to plug in a 1, a 1, and a 1, and I'm going to plug in -1, -1, -1. All right, go to work. Because you're talking about the most tedious part of the problem. So if you can't do this part of the problem, you belong on Live PD. So you should quit Tri-County Tech. Go to Richland County. What day is it?
Hey,
Wednesday?
23rd. Yes, sir.
Yeah. I don't have to pick up my son today. Don't want DSS calling me. Dang, old ex-wife bank got robbed yesterday. Oh, shut up, Hubert.
Whatever it was, TD or?
No, it was the Sun Trust up there at dang old Liberty Highway.
It said 3 of them got robbed yesterday.
Oh, it did?
South State got robbed yesterday too, didn't it?
I don't know nothing about that.
How stupid can you be?
So
Awesome.
that's pretty good.
Well, I'm talking about how stupid can you
That's
be
pretty
to
damn
rob a
good, 'cause,
bank
I mean,
in the middle of
they
the
catch-
Walmart parking lot in the middle of the freaking day. Like, nobody's going to see you.
Well, it is pretty smart to rob a Walmart, because then you can just walk in and just you'd blend right in. With
Yeah,
the
that's
people up
true.
there.
The one that robbed the one in Anderson, they still haven't caught him.
Well, he don't come across to me as a very smart person, so I don't know.
So they robbed the bank or a Walmart? Confused.
He robbed the bank that's in the Walmart parking lot.
Why would you rob a bank? Then you have the FBI investigating you. It's federally insured.
Live PD. Have you ever watched Live PD?
It's such a great show, yeah.
I mean, honestly, the mentality of these people are dumber than rocks. I mean, they are stupid. So you've got to think, you're not stupid. I mean, it's hard for you to think on that level.
The guys that assess the situation get on my nerves. That's why I can't watch it. They get on my nerves so much.
Well, that's what the mute button's for. I kind of like those guys. I mean, they're pretty. The guy on the right, the black guy with the bald head, he's funny.
I like the black guy. I don't like the white guy.
Yeah.
He's on my nerves.
I tell you what, no, I better not say that either. Deadpool will jump in too on that one. I'm not going to say what I was going to say. All right, so here we go. 1/3. Let me erase all this over here. Deadpool ain't even concentrating. He's not even listening. Told you, he's watching that dang old. I ain't gonna say that. 1/3 plus 1.
You wild.
Minus 1/4. I'm sorry, I can't hear you. Minus. All right, what is -1 to the third power? -1, and that's over 3. Plus -1. Now, a lot of you saying, why are you doing all that? Well, I don't want you to screw up a simple problem. And this is where y'all screw it up. Y'all screw it up right here. What is -1 to the fourth power? +1, Hubert. That's right, class. So we got to get a common denominator of 12. So put a 12 here, put a 12 here, put a 12 here. Unless you want to depend on your calculator so you can't make change where you work or spell mom backwards. 12, 12, 12. And that's a minus sign, that's a plus sign, and we got a negative right here. And this is going to be a -2. All right, so 3 will go into 12 4 times. That'll be 4. This is 1, 12. That'll be 12 over 12. 4, 3, 3, 4, 12, and 4, 3. And what's 4 plus 12?
16.
16 minus 3?
13.
You owe somebody $4, you owe somebody $12, you owe them 16. Minus 3, you owe them 19. So that's minus 19 over 12. Dang old 13 minus a -19 is 13 plus 19, which is what? 34, 32, what is it?
32.
32 over 12. Somebody give me that decimal, please.
2.6.
2 point what?
6, 7.
2.67 square units. Now, I don't have a problem with you punching that in a calculator, but I'm going to be honest with you. The people that can punch this in a calculator are about the same number of people that can read a tape measure. Not many can do it. Okay? I'm just telling you. Because it actually takes a lot of punching in and a lot of parentheses to actually do it, or a lot of steps if you do it step by step. So I'll be honest with you, it's going to be tedious either way you do it. Capiche?
Yeah.
Where did my piece of paper go? Oh, here it is. All right, let's try nerd. This time I'm going to let y'all do it. I'm going to let y'all do most of it. I think I did this one. I did one like it, but I'm going to do it again. F of x is equal to x squared, oh, it's minus 2. And y, or g of x, is equal to x. Notice I do not give you the points. Therefore, what? You need to calculate them. But first, I would graph it to make sure that I was in the right ballpark whenever I come up with those numbers. I had one student one time put 0 to 57. And it was only supposed to be like 0 to 2. But they calculated 57. I think that was Mr. Crawford.
You out of your mind, dude. I'm your best student you've ever had.
I know. Who is that inside of their mind? Or lost her mind? Which one is it? Who lost her mind?
She's out of her damn mind.
She's going to be teaching another class in the fall, a Polycom class.
Really?
Them kids don't know what the hell they just signed up for.
Whew, I think
that's what's killing your Polycom reputation.
Tell me about it. I told the two guys that's the head of the Polycom.
But
I told them, I said,
it's only easy because she gave us the answers to the tests.
Don't do that anymore.
The biggest fault in her class is the fact that you can't read her damn writing, dude.
Yeah.
Hieroglyphics, man.
That's what I've heard.
And it wasn't 8 o'clock, and I just don't do 8 o'clock. So
that don't do good with your schedule, you know.
No, it doesn't.
And we need to rectify that. We need to make sure our classes go with your schedule.
That's the thing. Valbonia's class, 8 o'clock we were starting the test at 8 o'clock.
Yeah, like we had a quiz. We had a quiz every single class, and that quiz started at 8 o'clock. She was taking attendance at 7:59.
Yeah, no, not like you were logging into Quizlet at 8 o'clock. Like she was hitting the start button at 8 o'clock.
I can't handle that.
It was rough.
But you made it.
A lot of the time, Hubert's later than I am.
What doesn't kill you makes you stronger.
I guess so.
Okay, that should be some type of picture you get. No sneezing in class. No, you suck. You're a failure. We got one person here that's finished and two that are drooling on themselves. They can't figure it out. So what are y'all doing? Y'all done?
Need like 1 more minute.
Okay. Did y'all find your intersection point? Why?
I don't know how.
Set them equal to each other.
I did that, but
Okay.
then I got x squared minus 2 subtract x is equal to 0, and then I don't know how to.
Okay, that's a trinomial.
I don't know what it
So you reverse FOIL. X squared minus x minus 2 is equal to 0. Or complete the square. You like to complete the square, which I do, but some of y'all have a heart attack if I do that. But anyway, my students won't, but some of y'all that hadn't had me might. All right, so that's going to be x, parentheses, x, and what's the multiples of 2? 1 times 2? We want a negative value here, so that means the 2 is negative because it's the bigger number. What does this mean, like or unlike? Unlike, so that's going to be a positive. So x plus 1 is equal to 0, and x minus 2 is equal to 0, and x is equal to negative 1, and x is equal to what?
Positive.
There's your 2 intersection points. So far, 100% algebra. No calculus involved. Now, I'm not doing that to embarrass you or you, because I know that there's probably 3 or 4 more students at the Pendleton campus and the Easley campus that didn't know what necessary. Okay? Because that is normal. It's normal to be sitting in an algebra class. I mean, my daughter. To be sitting in a calculus class and forget how to do algebra. It's very common. So there's a little refresher. And if you don't know what I'm doing there, then you are a disappointment and a failure, not just a failure. So you should be able to get that. Okay? So we've got a point here at negative 1 and a point here at positive 2. So step 3, set up your integration. So antiderivative from negative 1 to positive 2. Which one's your bigger value? Well, you can see that your bigger value is x. Okay? So I'm going to say x minus, parentheses, x squared minus 2. All right, now I want you to distribute that negative, and now you've got 3 terms that you got to take the antiderivative of. So that's going to be antiderivative from negative 1 to 2 of x minus x squared minus what? Be a positive 2. And I'm just going to rewrite this. Negative 1 to 2 of negative x squared plus x plus 2. Now just take the antiderivative, take the integral or the antiderivative of each term. And that's going to give you, what's the antiderivative of negative x squared? X to the third over what? 3. Plus x squared over what? Plus 2x evaluated at negative 1 then 2. What?
That 2 should be a
X. All right, now do your plugging and chugging. Now I'm going to do my parentheses, because if you walked into my class, if you walked into my office a year from now and asked me to take the antiderivative from -1 to 2, I would do this and then I would draw the parentheses. I've got several degrees, and that's not beneath me to do the parentheses. Why? Because I don't want to get the problem wrong. Y'all, meaning students in general, you don't need parentheses. And then you cry and whine when you get it wrong. I don't understand that. I guess it's some kind of pride thing. I don't know. Kind of like, dang old saying, MS-13 are people because you pride of the country. Shut up. So we've got parentheses, got a negative parentheses to the third power over 3 plus parentheses squared over 2 plus 2 times parentheses. Oops. And then minus bracket negative parentheses cubed over 3 plus parentheses squared over 2 plus 2 times parentheses bracket. And 2 goes in the top here. 1 goes in the bottom. So, what is 2 to the third power? That's a -8/3. 2 to the second power. 4/2 plus 4 over 1 minus, what's -1 to the third power?
Negative.
-1, but a negative out front changes it into a what?
Positive.
-1 raised to the second power is +1, so that's going to be 1 over 2 minus 2 over 1. Now, the common denominator of 2 and 3 is 6, so I'm just going to go ahead and change everything to a 6. Three will go into 6 2 times. 2 times 8 is what? 16. 2 will go into 6. 3 times 4 is 12. 1 will go into 6. 6 times 4 is 24. 3 will go into 6, 2. 2 will go into 6, 3. 1 will go into 6, 2. What's -16 plus 12? -4. -4 plus 24 is 20. So that's going to give us 20 over 6. Let me close this in right here. 20 over 6 minus 2 plus 3 is 5. What's 5 minus 12? -7, but a negative out front gives us a +7. Well, what is this? -7 over what? 6. So that's going to give us a positive 27 over 6. Somebody tell me what that comes out to be. I'm sorry, what?
4.5.
4.5 is your answer. 4 1/2 square units. 4.5 square units. Okay, now I'm going to take a little jump I've covered a lot of 5.6 and 5.7. Now, remember, your book, which I was going to pull up today, is going to put a lot of decimals in there. So you got to know how to do this before you can do your decimals. But I guess since the book is closed down today, we'll go over the book problems Monday. But I'm going to go ahead and assign some homework tonight as soon as I can get WebAssign to work.
You go back for a second.
Yeah.
Plugging the chug.
Mm-hmm. We're about to use D to right.
Yeah, I'm just.
Okay. All right. The next question I got, I'm going to shift over to the average value of a function. Now, of course, you don't have any idea what that means, but we're in 5.8 now. Okay. The average value of a function. So first of all, I'm going to go through right quick. I know a couple of people have got to leave, so I'm going to try to go through right quick. Finished?
Yeah.
Okay.
Can we come back to it after this class?
Yeah. Okay. First of all, if I asked you what the average is, a lot of you would say, well, that's where you take all the numbers and add them up and divide by how many numbers you got. Yeah, that's true. But it's also, the average is, in statistics, the number that represents uniform distribution. Okay? Now, the best way, I know we're not doing probability, but the reason I'm showing you this is uniform distribution looks like this. Okay? Where you have a straight line. Now, why would you want to make a curve into a rectangle? Because it's easier to do what? Find the area. Okay? So that's what they're doing in the 5.8 section. All right? They just want you to know how to do it. Okay? Don't ask me why. Okay? So to find the average F of AVE, you're going to take 1 over B minus A and multiply it by the antiderivative from A to B of F of X dx. Okay, so you need to highlight that because that is the formula we're going to be using. And even if you use a little bit of algebra here, multiply both sides by the common denominator, you're going to get F average of B minus A is equal to the antiderivative from A to B of F of X dx. But what the heck does that mean? Well, think about it. If this represents this thing right here, this straight line, that represents the average. Okay? So that's this guy right here. All right? Remember when we did the 50 miles per hour? All right? I told you y is equal to 50 miles per hour. And then I multiplied by what? 3. And I got 150 miles per hour, or 150 miles. B minus A is your what? That's your distance on the bottom. Or I could take the antiderivative. So what is the antiderivative of 50? 50x, and evaluate from 0 to what? 3. And what is 50 times 3? Calculus, algebra. You'd be surprised on how many people sit through calculus, 2 semesters of calculus, and they can't tell you that that's all we're doing is multiplying the length times the what? Times the height. You'd be surprised. But that's what you're doing. Algebra, calculus. Doing the same thing. Now, to find the average. Now, this will make sense in just a minute, okay? All right? Let's take, for example, this problem. 2x minus 4. F of x. I had to pull up some problems since the book didn't work this morning. 2x minus 4 from 1 to 5. Now remember, the formula to find the average, first of all I want you to graph it. 1. Graph it. 2, I want you to plug in the formula. Do the formula. And then 3, I want you to plot the average. Okay, so 2x minus 4, we know that the graph of 2x minus 4 has a vertical shift of 4 down. 1, 2, 3, 4. And it's x is a straight line, 45-degree angle, but the 2 makes it a little bit what? Steeper. So instead of going at 45 degrees like this, it's probably going to be going something like this. And they want you to go from 1 to 5, and I'm assuming that this is 1 right here. That's why you got to, 1, 2, 3, 4, 5. So we're talking about this area right in here. Okay? I'm assuming that crosses the C. 0 minus 4, 4, 2. So that's 2, looks like. 0 plus 4. 4 divided by 2 is 2. So this number is 2. So this number right here is 1. So they're wanting to know that area right there, if my pen will work. Right there. Now, what we're going to do is we're going to find a point here. I'm going to take this red and the average right here, I'm going to circle. We're going to find a point right in here. Let's say right in here. And this is going to give us a y and a what? X. And if I was to draw a blue line, a blue rectangle, like here to here, like that, that blue area from 0 to whatever will be the same as the what? The black area. That's why we're finding the average. The average will give you the area under the curve. Okay? That's what they're trying to tell you. Yes?
Do you go out, like, do you go out to 5 or do you go past 5?
No, 5 is it.
So you stop it at 5?
1, 2, 3, 4, 5. No. You'll figure that out in just a minute.
Okay.
I'll get there. We ain't got there yet. All right, so graph it. I just graphed it, and now I know what I'm looking for. Formula. F average is equal to 1 over 5 minus 1 times the antiderivative from 5 to 1 of 2x minus 4 dx. All right, now I want you to take, it's 11:35 right now, I want you to take a minute and do just that right there. You don't have to do any more, just take the antiderivative and hopefully y'all can do 1 over 5 minus 1. Take a minute And if you want to go ahead and start plugging in the 5 and the 1, go ahead. Go ahead and plug the numbers in. Mr. Miller, are you still with us?
Yes, sir.
You ain't fell asleep yet?
No, sir. Not yet.
He's just been in another room watching Andy Griffith show. No, he's been in another room watching Sesame Street. Yeah, by the whole thing, yes. I thought I took the assignment, but I didn't. I thought I took the attendance quiz, but I didn't. How do you think you took a quiz? Live PD. All right. So.
In his email, having stressed so much.
1/4 and 5 squared. I'm going to put 5 squared right here, minus 4 times 5, and I'm going to put that in little brackets, minus, little brackets, 1 minus 4, check my math, or plug it in. And that's going to give us 1/4 bracket. 25 minus 20 is what? 5. Minus brackets. 1 minus 4 is what? -3. And what's 5 minus a -3? Dang old 8. That's why Hubert uses brackets, parentheses. I guarantee you somebody got a 2. And I guarantee you $1 to a donut hole, if I ask them, did you use parentheses? They'll say, no. 2. Now, what is that? That's not the area. What is that? Somebody tell me what that is.
The average?
The average, which means y is equal to 2. So find x. What do you do if you want to find x?
2.
I heard a 2, yeah? You're going to use the 2. What are you going to do with 2? Come on, Deadpool. What are you going to do with 2? Okay, he's not going to talk to me. You're going to set the equation equal to 2. Isn't this y? Isn't this y?
Of course.
And y is equal to 2, so plug in 2.
So set it equal to it.
Thank you, Deadpool. 15 minutes later.
Deadpool, why?
6 is equal to 2x.
I like the movie, man.
X is equal to what?
I like the name Deadpool.
So you only have to do one.
It's like Forrest Gump, too. Does that make
Yeah, well, I think it has to do with the fact that you run your computers like, oh, you're probably watching Deadpool porn or something.
Hold on just a second. I'm trying to listen to 2 conversations at one time. So, the average, the point on the average is 2, 3. All right, what was you asking, Ms. Cuckoo?
So when you're trying to find like the point, so I should say the y, you don't have to plug in both of them. Oh no, you did. Never mind.
No, I just plugged in 2 because that's the only point I
No,
have.
no, no. When you're doing 5 and 1. But I
Yeah, I plugged in 5 right here.
yeah.
And I plugged in 1 right here. 1 minus 4. I skipped a step.
So 2 times 3.
Now, let me ask you a question. If this is 2, and we're supposed to make a rectangle, what's this one right here? If this is 2 right here, okay, I'm sorry, 3. If this is 3 right there, this is 3 right here, what's this? If it's a rectangle, if this is 3, what's this?
2.
3. If this is 3, this is 3. So your length is what? 6. What is your height? 2. So the area of this average is 12.
Why are you going out 3 more?
Rectangle. What's special about a rectangle? The sides. They're all equal, okay? Like a square.
Right.
All right? Okay? I know it's not a square. How do I know it's not a square? Because the length is not equal to the what? The height. The 2 is not equal to the 2. If it was a square, this point would be 2, and you put a 2 right, there'd be 2 here. It'd still be a rectangle because this right here is 2. 2 and 4. But since this is 3, 1, 2, 3, then what's this side over here? 3.
Wouldn't 2 and 3 still be a rectangle?
Yeah, it would be. I'm talking, I was thinking of something else, okay? This right here is 3 also, okay? So, figure, I want you to do now, I want you to find the antiderivative and go from 1 to 5 and tell me what you get. Go ahead and do that. Find the antiderivative of 2x minus 4 and plug in 1 and 5 and tell me what area you get. So somebody tell me what, I'll do this in green. What is the antiderivative of 2x minus 4? Well, it'd be 2x squared over 2 minus what? 4x evaluated at 1 and what? 5. Well, that cancels. So 5 squared is what? 25 minus what? 20. Bracket, and then minus 4 times what? I'm sorry, I just messed up. Minus bracket, erase that because I have to go through an act of Congress to get the eraser to work. So 1 would be what? 1 minus what? 1 minus 4. And 25 minus 20 is what? 5 minus a negative 3, which is what? 8. So the area under this curve is 8. And somebody's going to say, well, what about the 12? Well, I might not have done the rectangle right. I have to think about the rectangle. I don't know. But anyway, just don't worry about that right now. What's supposed to happen is the area here under the blue is supposed to be equal to the 8. And I'll have to find out what I did wrong. I must have done something wrong there.
Why is the right side of the rectangle equal to 3 if you're only going to 5?
That's it. Thank you. I think that's what you were bringing up. Okay. But I think you brought that up too.
So you can't draw it past where it's...
You can't draw it past. So somebody do that for me. What would that be? So it'd be 5 on the bottom times 2, right? That would still be 10, wouldn't it?
Yeah, too much.
Let me do some more research on this because it's in the book. I just got it. That book is so complicated. I gave up on it. But the blue area is supposed to equal the green. All right, and I've got to look at it, and I must have. But I think you're right. I think the 2 you can't go past 5. But I'll get it straightened out. I want to do one more. I got 10 minutes before some of y'all have to leave. A couple of y'all have to leave. So let's do one more, and I just want you to find the average, okay? All right. So f of x is equal to x to the second power from 1 to 4. All right, I'm going to give y'all 2 or 3 minutes to work this one. Remember the formula. 1 over b minus a times the antiderivative, blah, 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 blah. That's what I need. I need to give me an Escalade. It's about 6 years old.
Have you seen gas prices recently?
Yep, I'm watching it. Just because of Iran, just because
Priority 1 message coming in.
anything happens over in the Middle East, that the oil companies use it. That's why we're trying to get off of the oil. That's why we're trying to get off the, I ain't gonna say it, trying to get off the Mid East dependency.
So get you a Tesla. You don't even need gas.
No, don't think so. I ain't seen a Tesla hooked up to a gooseneck trailer yet, so I think I'm gonna stick with what I got.
I mean, they got instant torque.
Yeah. I'm sure they can pull a gooseneck full of cows or full of hay, either one, or a hay trailer.
For sure. I mean, say the least.
I don't even know pick a Tesla is, much less whether they can pull the trailer or not. Do what?
I've seen it beat Hellcats in a drag race.
All right. So we got what? 1 over what? 3. Antiderivative of 1 to 4 of x to the third, or x squared dx. So that's 1/3. Oh, my daughter. Just ignore it. 1/3 of.
Better phone off, please.
You probably want the money. X to the 4th, x to the 3rd over 3. Evaluated at 1 and 4. And she's going to call right back. Because, you know, if nobody answers, that means I'll call back until you answer. No, that's not what it means. It means I'm in class, dummy. Bye, PD. That's what I say to my kids. Oh, that pisses them off when I say that. Think. All right, so 1/3 brackets 4 to the 3rd power over 3 minus 1 to the 3rd power over 3. Now, that's some hard math right there. I don't know if some of y'all might need a calculator. 1/3 over 63 over 3. And 63 over 9 is what? All right, find the point. Well, what's the square root of 7? 7 is equal to x squared. X is equal to the square root of 7. Somebody take the square root of 7. What is it?
2.
I'm sorry, what?
2.65.
2.65 is equal to x. So the point, so if I draw this, and that's x squared, looks like this. And from 1, 2, 3, 4. From 1 to 4, we're talking a point of 7. So let's see. 1, 2, 3, 4, 5, 6, 7. So 7, I don't think I got it drawn right. Let's see, 1 and 1, 2 and 4. So that'd be 4. So that'd be 1, 2, 3, 4, 5, 6, 7. So 7 would be right in here somewhere. 7 and 2.65. Okay? And that is called the average. So make sure you can do 2 or 3 things in 5.6 and 5.8. Make sure you can find the antiderivative. Make sure you can find the area between 2 graphs or 2 functions. Make sure you can find the average. Okay? It's called the average value of a function. Is what it is. Now, Monday, we will go back over this, and hopefully I can pull up the book, and we'll pick some problems out of the book. And the only difference is that you're going to be working with decimals instead of whole numbers on this. Okay? Any questions?
Well, we're not going to be here Monday, so I assume.
Okay, well, Wednesday, whatever. Wednesday, thank you.
Why are we not Monday? Oh, sure.
Wednesday, let's see, Wednesday, Wednesday we'll go over the last section, and then that's when I'll wrap up all the homework, and then y'all know what comes after the homework. Fixed. Okay? All right, let me call the roll right quick. What time's class over anyway? 12:30? Okay, I'm letting y'all go early today. All right, y'all three are here, so y'all can go. All right. Everybody was here at the Anderson campus. Martin, 1, 2, 3. All right, man, have a good one. Clap.
Here.
Corley.
I think he dropped the class.
Okay. Crawford, do you know why? It wasn't because of Polycom, was it?
No, he was going to transfer to Clemson, but he decided not to, so he doesn't use the credits anymore.
Okay. I was hoping it wasn't because of that first day cluster. Crawford's here.
Here.
Field. Frederick.
Here.
Granger's here. Hethorn.
Here.
Lehrer.
Here.
McKenna.
Here.
And Miller. Okay, Pendleton, y'all can go. Evans.
Here.
Griffin.
Here.
So,
Holiday. Cole.
Here.
Nethercutt.
here.
Mr. Phelps is here. And Abels.
Here.
All right. Y'all have a good weekend. I'll see y'all Wednesday or something like that.
So, for the test online, will the in-class part be like the syllabus bonus questions and stuff?
I'll give y'all some math questions, but they'll be very easy. I only do it just so keep the administrators off my back.
Okay.
So it'll be like questions like we're going over right now. Be 5 questions.
Okay, and I know initially we had like homework due Saturday, but you extended the date. Will the test be like a Saturday thing, like over the
7
weekend?
days. I give y'all 7 days.
Okay.
Okay.
Yeah. Just wait until we get there. We haven't got there yet, so we still got Wednesday to go. So y'all come to class Wednesday, probably Wednesday, about the second half of class, I'll go over the test and I'll post it and I'll cut off the homework and I'll put the due dates in, and that will answer most of y'all's questions.
Okay.
Okay?
Thank you.
Have a good one.
You too.